So guys, you can see the LED is blinking, and it is blinking after a half a second delay. So let me show you the code. Now in the code, you can see that we just did the configuration. We just programmed the configuration bits. We set the oscillator to be high frequency because we are using a 20 megahertz crystal. We defined the crystal. Then in the one-time loop, we defined the direction of the port and pin on which our LED is connected. Then we gave the initial state that by default the LED will be off. After that, we turned on the LED in the forever loop, and it remained on for 500 milliseconds, then turns off and remains off for 500 milliseconds. Since this is in the forever loop, so it keeps on repeating forever. So this coding gives us our desired result, which is over here, an LED blinking. Hello guys, welcome to learning microcontrollers. In this lecture, I will be showing you how you can blink an LED with a PIC16F877A microcontroller, and we will be programming this circuit on MPLAB X IDE, and we will also give you a hardware demo. So let's get started. First of all, set up the hardware, which is just a basic LED connection with the PIC. So I have this one PIC16F877A DIP version having 40 pins, and this is the LED I'm going to use, 5mm crystal type, having 2 pins, one longer, one shorter. Longer is always the power and shorter is always the ground. First of all, connect the ground pin directly with the ground of your PIC. Now to connect the PIC kit and rest of the circuitry required to program the PIC, I will share a link, or in the introductory section there is a lecture on setting up your PIC16F877A hardware. You have to go through that if you don't know. So rest, if you know, then that is how you will do it. Connect the ground to the ground of your PIC. Power, you do not connect the power pin directly to the PIC16F877A any pin, because it will get burned. The LED will get burned. So we will use a safety resistor. It can be of any value from 100 ohm to onward. The higher the value, the dimmer the LED will go. So for a 5 volt supply, I will be using a 220 ohm resistor. It will give me a very good amount of brightness. So to connect it, you connect the longer pin of your LED to the one end of this 220 ohm resistor. From the other end, I will connect it to any available digital input output pin. Here I have all the pins available. I'm going to connect it to pin number B0 like this. In this way, the connections are completed. So now we will program this PIC using MPLAB X IDE. So let me show you the hardware, then we will move on to the programming. So guys, this is the hardware that I have over here. You can see I have just connected a shield. This is my PIC16F877A. Here I have the PIC3 programmer tool, which will program the circuit and will also be responsible to power up this circuit as well. Like I will use a 5 volt coming from the PIC3 to power up the circuit for demonstration. Here this LED, I will use this LED. This is connected to pin number B0. So this will be the LED that will blink once we write the code. So let's get to our MPLAB X IDE. So let me open the MPLAB X IDE. Here it is. I have version 6.30. You can go whichever version is available to you. Latest is always better because it's a free software. You do not need any type of payment to buy it. So you can just update it whenever you want. So we wait, let it turn on. It takes some time to load up. So you have to be patient when using this. So there we go. Now first of all, let me zoom in. Go to the left, click on File, click on New Project. This window pops up. Select the microchip embedded application project. Click on Next. Then you select the microcontroller you're going to use. It will be a baseline 8-bit MCU PIC16. So I write the name here, PIC16F877A. Here it goes. Select it. Tools, no tool. Click on Next. And now XC8 is a compiler that we use. Select it. Click on Next. Write the name of the project. LED blinking tutorial by learning microcontrollers. There you go. Now I click on Finish. We wait. Now on the left side, you will see that the project has been built. I don't want to see this one. Okay, let it remain there. Okay, also I close this one. the older project. There you go. Now on the right side, you see there is no coding window or something like that, because you have to make a C file to start working. First of all, go to the source files, expand it, right click on it, click on new, main.c file. That's what you need. Now write the name. I write LED blinking tutorial by learning microcontrollers. Now this is the .c file we will have. Select C, click on finish. Now you will notice that the file is created over here and the coding window has just shown up. That black window was not related to this. I just close this. This is something else. Okay, there you go. Now what I do is that we have to first of all do the programming. To do the programming, you have to do some configuration of your PIC here. If you don't do the configuration, then there is a possibility that the code will not work, because you have to select the type of oscillator you are going to use, the frequency you are going to set. These things come by default in micro C, but here you have to do that yourself. So you will go to the window. There you have this tool called target memory views. In that you have this configuration bits. Click on it, and below you will see this. These are the bits that you have to set. For every microcontroller, like if I use a better microcontroller, there will be more type of configuration bits available. But for PIC16F877A, these are available. First one is the FOC, that is the frequency oscillator. You just click on it and select HS, because the crystal I am using is 20 megahertz. If your crystal is above 8 megahertz, 8 to 20, then you will go HS, high frequency oscillator. So if it's not, then you can just go EXTRC, external oscillator, HS. And then for the void talk timer, I don't want it. You can keep it on if you want it. Then power brownout reset, let it be. Low voltage, no, we will not have it. We do not need the MCLR pin. Now if you enable it, then your MCLR pin requires to be used for programming, while if you don't disable it, then that's not required. Rest of the three will remain off. This is for your program memory protection. You can enable it if you want your code not to be stolen by anyone. If they try to read, they will not be able to read. So I will make a lecture on this, how to use it. So there you go. Now once you are done with the configuration, now click on generate source code. Now this is the configuration code. You copy it till here. Go into your code. Paste it either above or below this. There you go. Now there is a configuration. Now one more configuration is left. That is, we have set the type of oscillator, but what is the frequency of the oscillator? But that unfortunately you have to write. You can just write it once and copy paste this template whenever you need it. You have to write it like this. Define X tall underscore frequency. Now write the frequency. Now I want the frequency to be 20 megahertz. So if it is 20 megahertz, then there will be, like for mega it is 6 zeros. So 2, 1, 2, 3, 4, 5, 6. Now to make it 20, we add another 0. So this will be 20. So 1, 2, 3, 4, 5, 6, 7. So it's 20 now. 20 megahertz of frequency. You can also take help from the internet as well to make sure that you are doing everything correctly. So we go to the net. Here we go to MHZ. Let's see how much MHZ it is. If my internet is working quick enough. So 20 megahertz, so that is perfect. Okay, now we have the basic requirement set up. Now you can just remove this return, not required here. Just remove this, we don't need it. Now we start writing the code. This is our one-time loop. In the one-time loop, I would like to, as shown in the presentation, we are using pin number B0 of our PIC16F877A, on which the LED is connected. See, it's B0. So we initialize this pin as an output pin because it is going to send a signal to the LED. So it will be an output pin. To declare it as an output pin, we have to use the trace register, and we write it like this. You will write trace B bits, because I'm not going to initialize the whole port. I will just initialize the one pin, that is B0. Automatically it comes here. So you can just write trace B0, that is pin number 0 on the PIC16F877A, like this. There you go. Now equals to 0. 0 means the pin has been declared as output, 1 means it has been declared as input. After that, by default, I want the LED to be off. Then we send a signal, port B. Then we write bits because we are dealing with a bit. Dot B0, just press enter, equals to 0. Now, by default, the LED will be off. We have defined the initial state using, now we are sending, here we are just defining the direction of the LED. Here we are sending a status to the LED, that is low, 0. Now, after that, we can go for the forever loop. For the forever loop, I will use while 1. This will make a forever loop here, starting from here and ending over here. There you go. Make sure the brackets are correct. Okay, only 2 brackets, one is this, other is this. Okay, that's perfect. Inside it, we will write our rest of the code. First of all, to blink an LED, we have to turn it on. So we just copy paste this line. Instead of 0, I make it high. The LED is on. Now we need to keep it on for a certain period of time. We give delay. To give delay, you use this command, delay underscore ms. Now write the delay. 500 millisecond is enough. Like this. Now this command will make the LED go high. This command will pause the code. So this means that the LED will remain on for 500 millisecond because the code is paused. After that, we copy paste this again, just like this. Now we are having 2 errors here. Okay, you can just click on it. It will show you identifier cannot be found. So as far as I know, this underscore is not enough here. You usually do not use an underscore for delay. You have to use, I think, 2 underscores that I remember, like this. So they are usually 2 underscores, not 1 for the delay. Now this is perfect. So you have to be careful because it's a case sensitive language. Now there you go. This is our code. We config all the configurable bits for our PIC16F877A. Then we set the crystal frequency. After that, we define the direction of the pin on which the LED is connected. Then we gave the initial state, that is LED must be off when the code runs. After that, we initialize the forever loop. After that, we turn on the LED in the forever loop for 500 milliseconds. And after that, we turned it off. Here it is to turn off, then give it 0. The same state, that is the initial state. Then we turned off the LED for 500 milliseconds because LED is off here. After that, it remains off for this much duration because we have delayed the code. After that, this code will keep on going here like this forever because it's a forever loop. So in this way, the LED will keep on blinking forever. So let's try this code. Now to try this code, you have to go to the production. There you have to build main project. You have to click on it. This will build the project. You have to wait. If there is no error, it will build successfully. Okay. No error, build successful. So the project has been built. There your files have been created. So you can go there and get the hex file for your microcontroller. Now to use a hex file, the problem is that I have a PIC3 which is a clone version available at my place. So I will not be able to use this directly to burn the code into the microcontroller. So I will be using my PIC3 programmer tool. That's an alternative. I also have a lecture on this in the introductory section. You can just go and watch this to get, in that I have shown you how to use and download this. So you can just do that. It's a free tool. First of all, select your microcontroller on the PIC3 programmer tool. That is PIC16F877A. Latest version of this tool automatically detects the microcontroller. So you can go with that. Click on read to make sure that your microcontroller is working perfectly. There you go, it's working. Now we just have to import the file. This is the location, users, MPLAB X. Okay. We go to file, click on import. Okay, it says go to drive C. Okay, there below this PC, drive C, users, this one. there we have something called MPLAB X, this one. Okay, this is the video, and then it says distribute default production. Distribute default production. There we go. This is the hex file, hex. Open. Okay, there you click on write. Now wait for the program to be written. Okay, erase failed. We have to make sure that the pickets is connected correctly. Okay, I changed the programming port because I think the programming port I'm using is wrong. The wire, I'm using an extension. Extensions sometimes create problem. So I have to use the other extension. I may directly plug it into the computer, make it work. Okay, there you go. I have directly plugged it into the computer. Now, since the pickets have been reconnected, you have to go there, click on tool, check communication again. So detecting pickets it's successfully detected. Okay, now click on file because it's already selected. See, it was the problem with the extension cable that I was using. Now the code is burning. So you have to wait. These two pins, you can see the LED is connected to pin number 39 and 40. These two blink when the code is burning because the same pins are also used by programmer. So you can see the LED is blinking. So this means our code is working perfectly fine. So this is it, guys. You can see the code is working. Our LED is blinking. So that is what we just wanted to do. So guys, this is it. I hope you guys learned something from this lecture. If you guys have any questions, please do ask. We'll see you in the next lecture. Goodbye until then.